Esteemed scholars, welcome back. Remember that in the last lesson, we established the fact that the equality of surds is used to find the square root of surds. Let us now take a few examples on the square root of surds. Example 1. What is the square root? The square root of 1 minus root 2, for instance. What is the square root of 1 minus root 2? Here is our answer. You come here and say, assume a square root for it. Let the square root of 1 minus root 2 be root A plus root B. If you like, since here is minus, you can put minus. If you also put plus, you won't have any issue. That is, with this assumption now, we are saying square root of 1 minus root 2 is equal to root A minus root B. That's what we are saying. Then how do you get the square root sign of this number? It is to square both sides. Square both sides as follows. Square both sides as follows. So you have bracket opens, square root of 1 minus root 2, bracket closes, square, is equal to bracket opens, square of A minus square of B, bracket closes, square. The square will cancel the square root, leaving us with 1 minus root 2 on the left hand side. On the right hand side, this is a perfect square. What it's saying is square of A plus square of B minus 2 square of A 2 square of A square of B. That's the implication. This will give us 1 minus 1 minus root 2 equal to the square of root A is A plus the square of root B is B. Then minus 2 root AB. 2 times root A times root B is 2AB. Now this will give us 1 minus root 2 equals A plus B in brackets minus 2 root AB. This is where the concept of equality of surds come in. This is the constant, that is the constant. So it means that 1 is equal to A plus B. Then minus root AB will be equal to minus 2 root, minus root 2 rather will be equal to minus 2 root AB. So come here and say, using the equality of surds, using the equality of surds, A plus B is equal to 1. So we can say A is equal to 1 minus B. That's equation 1. Then minus root 2 will be equal to minus 2 root AB. Implies that, what does it imply? Minus would cancel minus. So it implies that root 2 is equal to 2 root AB. So the square of root 2 will be equal to the square of 2 root AB. The square of root 2 is 2. The square of 2 root AB is 4AB. So this means that 2 over 4 is equal to 4AB over 4. Two over 4 is 1 over 2 equal to AB. We can leave this as equation 2. And so now we substitute equation 1 into equation 2 as follows. What that one implies is whenever we find B in equation 2, we can replace it with 1 minus A. This is 1 minus A because A has come over. We replace with 1 minus A. So that will give to us half is equal to A into 1 minus A. So we open up the right hand side through expansion. And so we are going to get half equal to A minus A squared. How? A times 1. A times A square, A times A squared. This will give us 1 equal to 2 times A minus A squared. And this will give us 1 equal to 2A minus 2A squared. This will give us 0 if we move 1 to the other side, equal to, or rather let us move 2A and minus 2A squared to this side. If they come over here, we have 2A squared minus 2A plus 1 equal to 0. This equation is quadratic.
We interrupt our program to bring you this important message.
Then we can solve it using the quadratic formula. So we have using the quadratic formula, otherwise called almighty formula. A that we are looking for will be minus B plus minus square root of B squared minus 4AC, everything divided by 2A. The A on the right is different from this one. It's different from the A here. The A on the right is the coefficient of A squared. The B is the coefficient of A. The C is 1. So where A equal to 2, B equal to minus 2, and C is equal to 1. So it thus means that A that we are solving for, A will now be minus 2 plus minus square root of minus 2 square minus 4 into A 2 into C 1. So A will be equal to 2 plus minus square root of minus 2 square is 4. Minus 4 times 2 times 1 is minus 8. Okay, here we have over 2A is 4. That's 2 times 2. This will give us over 4. A will be equal to 2 plus minus square root of minus 4 over 4. This is going to give us A equal to 2 plus minus 2I. Why? Square root of minus 4 is a complex number. Just an aside, when you have square root of minus 4, it's a complex number. It's the same thing as saying square root of 4 times square root of minus 1. Square root of 4 is 2. Square root of minus 1 is I. 2 times I, 2I. That's how we got that. Over 4. A equals, this means 2 over 4 plus minus 2I over 4. So A will be half plus minus half I. If we expand this, we are going to get half plus half I, or half minus half I. This is the answer of A. These two values will now be substituted into our equation 1 to get B. If we do that, we would get, so we are saying recall that B is equal to 1 minus A. Hence, B is equal to 1 minus, this is the first value of A, bracket opens, half plus half I, or 1 minus, then we put the second value, bracket opens, half minus half I. That will give us 1 minus half plus half I, minus half I, while minus times half minus half, minus times minus times plus half I minus half I, or 1 minus half plus minus times minus is plus half I. 1 minus half is half. Then we have minus half I, or half again plus half I. So you notice that the two values are almost the same. It's just an alternation. So it means that we can therefore say that the square root of 1 minus root 2 is square root of half minus half I minus, half plus half I minus square root of half minus half I. This is the A that produced that B. Or we take the second set of value, which is merely an alternation, and that will give us square root of half minus half I, or minus square root of half plus half I. So this or that is the square root of 1 minus half. This is a classical application of the concept of equality of sorts to find square root of numbers. We are yet going to take a second example in the course of this lesson. Thank you for staying with us. Don't forget to continue to like our videos or share or repost them. Ultimately, do subscribe to our channel if you are yet to do so. Thank you.